Year 8, going to do the test and corrections. If there's any questions that you've got right, just skip ahead on the video and go to the questions that you need help on or support on. And let's start with question 1. Okay, question 1A. Write down a single transformation that will move A onto B. So here's our triangle A, and for it to go to B, it's a translation. That's the type of transformation. It's a translation because it hasn't been rotated, hasn't been enlarged, and the type of transformation is translation. So moving across 3 steps to the right, 1, 2, 3 right, and 1, 2, 3 up. So you would need to write this as a vector, 3 right, 3 up. They're both going to be positive. 1B, okay, 1B is E onto F. So our triangle E, if we can get it perfectly done, okay, E is here, and type of transformation is a reflection, because if we translate it, it doesn't fit onto F. And just a quick check, transformation, we're going to flip on the y-axis, and does it move to F? Yes, it does. So the type of transformation is a reflection, and it's been reflected at the y-axis. So that would be the answer to 1B. 1C, B onto E. So here's our triangle B. If I can get it rotated, so let me just... So here's B onto E. Again, it's not a translation, it's more of a rotation, and we'll see what kind of rotation that is. It is a rotation, it's been rotated. Look at our square. Our square has been rotated 90 degrees, and one more 90 degrees is 180 degrees. And where it's been rotated, well, if we've put a little cross at the origin, you can see that the origin, or the cross that's been on the origin, doesn't move. So it's been rotated at the origin. To get the full marks, you need to write rotation, and it's been rotated 180 degrees at the origin. Make sure you write your degree sign, couldn't do it on computer, so 180 degrees at the origin. Moving on to D, they've been asking us to single transformation from C onto B. Okay, so where is our triangle C? Triangle C is over here, and triangle C onto B is another type of rotation. Again, the rotation is 90 degrees, because we just moved the square once, 90 degrees, and it's rotated at the origin as well. So rotation, 90 degrees at the origin. There's another keyword that you need to include for rotation, and if it is clockwise or anti-clockwise, well, we've gone clockwise in the same direction as the clock, so it's 90 degrees at the origin clockwise. Okay, moving on to question E. A onto D. Let me get this perfectly straight again. So A onto D. Well, it hasn't been rotated, no enlargement, it's not a reflection, it's just a single transformation, and it's been translated, so it's just been moved. It's gone 2 left, and 1, 2, 3 down. 2 left, so -2, 3 down, -3. Okay, moving on to question 2. Just going to label question 2 A, B, C, and D with the corresponding angles that we need to work out. And question 2A, remember, if you got this right, move on, don't look at it if you've already got it right. Now 2A, the angle we're given is 115 degrees, and the angle that we need to work out is A. You can see it's an alternate angle, so to give our answer, A is going to equal 115 degrees, and the reason is because alternate angles are equal. Moving on to B. Again, the angle we're given is 54 degrees, and the angle we need to work out is B. You can see that 54 degrees is going to equal B with the same angle, so B is equal to 54 degrees, and the reason for that is because corresponding angles are equal. They both correspond to each other, they are equal to each other. And moving on to C, the angle we've got is 141 degrees. The angle we need to work out is C. This is co-interior angles inside a pair of parallel lines, and co-interior angles sum up to 180 degrees. So to work out what C is, we have to do 180 subtract 141, and that means that C is equal to 39 degrees. And the reason for that, to get the full marks, is because co-interior angles sum to 180 degrees. Moving on to part D. Again, D, you can see the angle that we're given is 96, and the angle we need to work out is D. Let me just draw this perfectly. So 96 degrees is here, and D is there. Again, this is going to be a corresponding angle. If you move it up the line, angle D and 96 are equal to each other. So to get the full marks, I'm going to write down D is equal to 96 degrees as corresponding angles are equal. And this will get the full marks. A lot of you just wrote down the angle size, and it's not wrong, but to get the full marks you must give your reasons. Moving on to question 3. Question 3 says, copy the line AB and the point C. Construct an angle of 45 degrees from point C onto line AB. Now, around 80% of the class got half the marks. The reason they didn't get the full marks is because you had to construct the 45-degree angle. We've just constructed a 90-degree angle. Right, the tools you'd need, remember, is going to be the compass. So if I get the compass up, I have to get the compass up. Tools, maths tools, compass. And the first step you need to do is you need to create a 90-degree angle. And get your compass, put it at point C, and draw an arc from point C, and do the same thing on the other side. So draw another arc. Now these lines from point C to the arc is going to be equal because it's part of a circle. Now that you've done that, we put our compass needle at points that are intersecting. Make sure it's a little bit over halfway across C, and draw your arcs above C and one below C as well. Make sure you don't change the length of the arcs. Then move your compass without changing the length on the other side. Then draw another arc right below C and one more above C. Now the line that you've drawn, or the intersections that you've done, we can join up together like so. Make sure they are perfect. Now what you've created here is a 90-degree angle, a perpendicular line. Well, half of the perpendicular line is going to be 45 degrees. So we need to bisect this 90-degree angle to give us the 45 degrees we're looking for. Right. So to bisect this line, again, I'm going to use a different colour for this so you can see what's really happening. Let's see if I can get it. Okay, so draw an arc that will cross this angle here, this 90-degree angle. Then draw an equal length arc right over here. So where they intersect is where we're going to put our needle. And you don't have to change the length of the arcs when you put it onto the equal intersections. However, make sure you keep them the same. Draw one arc there. Move your needle onto the other side and draw another arc right there. So we've just bisected this 90-degree angle to 45 degrees. And it will be at this point all the way across. There you go. There is our 45-degree angle that we've bisected. Make sure you have a go at this. Again, you can rewind the video if you want to have another look at it. If you want to see another video, I'll put a link on YouTube on somebody else doing it with a real pen and paper, not on a computer. And here's the 45-degree angle that we were looking for. And this would get you full marks. Question 4. Copy the arrow onto square paper, enlarge the arrow by scale factor of 2 from the point O. So here's the center of enlargement that we need to work with. There's many methods you can do on this. One method I like is writing down everything and then working across with a scale factor of 2. So remember, scale factor of 2 means 2 times bigger. So scale factor of 2, everything you're going to do is make it 2 times bigger. A few students doing a shortcut way, but I like doing it properly so you can see what's going to happen with this question. Okay, so using a red pen. Starting with O, pick a point on the shape, anywhere on the shape. Just start with anywhere really. There is a good point. And you notice you go 3 right and 2 up. Now, since it's a scale factor of 2, you're going to do this twice from center of O. So 3 right, 2 up, 1 more, 3 right, 2 up. So this new point there is going to end up there. Picking another point, I'm going to pick here. Again, starting from O, it's going to be 5 right, 2 up. So we have to do this twice. So 5 right, 2 up, 5 right, 2 up. It's going to end up there. The next point we're looking at is going to be here. And from the origin, 2 right, 4 up. So we have to do this twice. 2 right, 4 up, 2 right, 4 up. It's there. Picking another point over here, let's say. It's 3 right, 4 up. So do that twice, scale factor of 2. 3 right, 2 up, 3 right, 2 up. It's right there. And got 2 more left. So let's go to this point now. Let's see where this point is going to be. This point is 5 right, 4 up. So doing that twice, 5 right, 4 up, 5 right, 4 up is there. And I think we missed this point. This one is going to be 6 right, 4 up. So we have to do this twice. 6 right, 4 up, 6 right, 4 up. It's right there. And the last point over here is going to be 4 right, 5 up. So 4 right, 5 up is right there. And all we have to do now is join up the dots to form our shape. And here's the enlarged shape. Moving on to question 5, draw a point. 2 points are 6 centimetre apart. Label them X and Y. So we need to draw a 6 centimetre line. So this is going to be my 6 centimetre line. Use a ruler and compass to draw all the points that are the same distance from X and Y. Remember, this is going to be the perpendicular line that bisects the 6 centimetre line. And again, we need to use our compass. So to bisect this line, make sure that you're a little bit over halfway. Don't do it halfway, please. Not even a tiny bit. Make sure you're plenty away from the halfway, and then draw your 2 arcs. So here's my first arc. Now leave the compass alone and make sure it's the same length. Do one right below it, another one right here. And move the compass now. Don't touch the length, put it on the other end. And draw 1 arc above. And 1 arc below. Where they intersect or where they cross is where you're going to draw your straight line. Now, a lot of you did it from points to points. Now, there's nothing wrong with that, but make sure you extend your line above and below the intersection. It's a nice way to show, hey, I know line's infinite, and you can go across those lines. And make sure you draw your right angle or perpendicular line. Remember, any point that you pick, let's say there, it's going to be equal distance to this point and that point. Even if you do that, this is equal distance apart from points X and Y. A few of you have done this to show that you understand it, and I'm very happy, but you don't have to do that. You don't have to show that these lengths are equal apart. Just draw the straight line. Don't waste your time in an exam doing that. Okay, question 6. Question 6, by far one of my favourite questions. A lot of students got this right, but the problem was when they were working it out, there was too much working out for something that didn't require that much working out, and I'm going to show you how quickly you can do this. Okay, 6a, what they wanted you to notice was that this angle 72 is a corresponding angle to 2x and x. Can you see that? So this 72 is equal to 2x and x, and we need to sum these angles up. So 2x plus x is equal to 3x. And to get what x is, we just have to divide by 3, divide by 3, and 72 divided by 3 is 24 degrees, which is equal to x. A lot of students got 36, well not a lot, a few students got 36s because they thought that 72 was equal to 2x. You can clearly see from the question that 72 and 2x are not equal. Yeah, 72 and 2x are not equal. It's 72 and 2x with x, so 3x. Now moving on to question B, 6b. 6b, you need to have noticed that this is 2x and 3x are part of a straight line, and if we were to draw this 3x, it would correspond with the one above, so we can write over here, this is also 3x, so together they make 5x, and 5x, this whole angle is equal to 180 degrees because the angle's on a straight line, and to get what x is, all we had to do was divide by 5, and x equals 36 degrees. Okay, so this was the only question, 6a, that some didn't get 24, they got 36. Majority got this right, well done. If you want to have more practice on these type of questions, I will put them up right now so you can have a go. Pause the video and have a go at them, and I'll show you the answers. Have a go at these questions, please, and if you want, you can skip ahead. Okay, right. Very quickly, these are corresponding angles. Corresponding angles are equal, so 2x plus 10 must equal 4x minus 20. Again, remember with these kind of questions, which side has the smallest amount of x? It's the left-hand side, so we need to subtract 2x on both sides. Subtract 2x, so you get 10. These cancel out, you get 10 is equal to, well, 4x minus 2x is leaving us with 2x. And we've still got the minus 20. To get x on its own, add 20 on both sides, add 20. And so 30 is equal to 2x, as minus 20 and 20 cancel out. Now divide by 2, divide by 2, and that will cancel out, so you're left with x is equal to 30 divided by 2, which is 15 degrees. So x is 15 degrees. And plug it into there. If they're the same angle, if they're corresponding, your x is right. So 2 times 15 is 30, plus 10 is 40 degrees. 4 times 15 is 60. 60 take away 20 is also 40 degrees. Since they're equal, because they're corresponding, our x must be correct. 4x and 5x, well, we know co-interior angles, they sum up to 180 degrees. These are co-interior inside a parallel. So 4x plus 5x is equal to 9x, and 9x is equal to 180 because angles inside a parallel line or co-interior angles sum up to 180 degrees. Divide by 9 on both sides, divide by 9, so that will go. So x is equal to 180 divided by 9, which is 20 degrees. Again, you can substitute it into 4x and 5x to see if they sum up to 180 degrees. The last one, x is corresponding to this angle here, so this angle is also equal to x degrees, and angles on a straight line, this is a straight line, what do they sum up to? They sum up to 180 degrees, so x minus 50 plus x, because I need to sum up 280 degrees. And we can simplify this. We have a plus x and an x. Remember, sign in front of the term belongs to that term, so plus x and x make 2x. And we still got this minus 50 degrees, so it's going to be minus 50. And it's still equal to 180 degrees. So we just simplified that, so 2x minus 50 is 180 degrees. To get x on its own, deal with the number first. Plus 50 plus 50, minus 50 and plus 50 cancel out, and you're left with 2x is equal to 180 plus 50, which is 230 degrees. Divide by 2 on both sides to get rid of this x. So x is equal to Well, 130 divided by 2 is going to be 115 degrees. Ooh. Yeah, 115 degrees. Let me just make this nice and neat. So equal to 115 degrees. We can substitute it into there to see if it's right. We know that's going to be corresponding. So 115 degrees there. And 115 take away 50 is going to leave us with 65 degrees. Do these sum up to 180? Well, yes they do. 65 plus 115 is equal to 180 degrees, which is angles on a straight line. Question 7 has to be my favourite question. You have to prove that the sum of the four angles, A, B, C and D, of this quadrilateral is 360 degrees. Now these are your external angles. We know that the internal angle of any quadrilateral sums to 360 degrees, and we have to use that fact somehow, and the letters as well. What you would need to start off doing is like this. Let's start off with the internal angles. Now this internal angle, this blue angle here, that I'm going to label, is going to be 180 minus D. Can you see why? Angles on a straight line, and if we take away this D, we're going to be left with this blue angle there that we've labelled. So it's going to be 180 minus D. This angle here that we're going to label with the red colour is going to be the same situation as this one here. So it's going to be 180 minus A. So 180, take away A, we're going to be left with this red angle. And this dark blue that I'm going to use is going to be 180 minus B. And the last one, this orange one, is going to be 180 minus C. We know that the blue angle plus the red angle plus the dark blue angle plus the orange angle. So if we sum up all these three angles, they should sum up to 360 degrees, because angles in a quadrilateral add to 360 degrees. So let's start doing that. Let's start actually working it out. So let's sum up these these angles. So 180, 180 minus D plus the 180 minus A plus the 180 minus B and plus the 180 minus C. If we sum them up, that should give us 360. So let's start doing that. Now 180 plus 180 plus 180 plus 180 is the 720 degrees. But minus D plus minus A plus minus B plus minus C is just going to be in letters, because we don't know what they are. So minus D plus minus, so plus minus, saying that in our head, is just going to be minus. So plus minus A is just going to be minus A, plus minus B is going to be minus B, plus minus C is going to be minus C, and these add up to 360 degrees. So let's tidy up a little bit. I'm going to make this a little bit smaller so we have more work space. I'm going to move it to over here. This is our working space. Just going to copy this out again. 720 minus D minus A minus B minus C is equal to 360 degrees. Now I'm going to subtract 360 degrees from each side. Or we could do something else. Let's start with something else. Let's move all of these letters onto the other side of the equation, because we can make them into positive numbers. If we add d on this side and add d on the other side to balance the equations, minus d and plus d go, and we've got 720 minus a minus b minus c is equal to 360 degrees plus d. So we just made this d positive by putting it on the other side. And if we do this step with all the others, so if we add a, add b, add c, these a minus b minus c will cancel out with add a, add b, add c, and they go positive on the other side. So we've got 720 degrees is equal to 360 degrees plus a plus b plus c plus d, because if we add them on this side they will cancel out. And if we add it on this side, it will also cancel out. And now we've got 720 degrees is equal to 360 degrees plus a plus b plus c plus d. Now, what should a plus b plus c plus d be? Because we've got 360 plus these numbers to give us 720. So a plus b plus c plus d must be 360 degrees, because 360 degrees plus 360 degrees is 720 degrees. If you don't like that, cover-up method, just subtract 360 on both sides. This will cancel out, and you're left with, well, 720 to take away 360 is 360 degrees, is equal to a plus b plus c plus d. So the sum of a, b, c and d is 360 degrees. It was a long proof, but it's a lovely proof. Hope you've enjoyed the last one. It is quite a challenge, but it's a nice way of showing that the external angles of quadrilateral add up to 360 degrees. If there's any other questions that you'd like to ask me, you can always ask me or any of the teachers in school. Make sure that you use a red pen and enjoy.